Raw, uncut, and unapologetic. Welcome to Men Talking Mindfulness.
Understanding pain is important because it can affect how much things hurt and how much your body can do to tame the beast. This is a quote from pain scientist and our guest on today's show, Dr. Lorimer Mosley. Welcome to the Men Talking Mindfulness podcast. I'm John McCaskill, and each week, my co-host Will Schneider and I, we do our best to break down and demystify an aspect of mindfulness and make it meaningful to you. This week, we're jumping into that subject of pain, and thanks to Dr. Mosley, we'll be looking at it in a way most of us haven't done before. We'll be discussing how meditation and mindfulness can affect your perception of pain, how your understanding of pain affects how much you hurt, how your body learns pain, why this isn't more commonly known information, and when and how pain is good for you.
And here is the bio for Dr. Lorimer Mosley, who we are told to call Laws. Is that correct, Dr. Mosley? Laws? Like, you know, Laws.
Sounds pretty good. You're saying that very Australian-esque.
I feel like a brother, Australian brother already. Awesome. So, Dr. Lorimer Mosley is a pain scientist, educator, and clinician. He has authored over 400 scientific articles and 7 books. His contributions to our understanding of how pain works, why pain sometimes persists, and what we can do to reduce persistent pain has been recognized by awards or prizes in 14 different countries. Wow. And check this out. In 2020, Dr. Mosley was made an Officer of the Order of Australia, his country's second highest civil honor for, and this is a quote, distinguished service to humanity at large in the field of pain and its management, science communication, medical education, and physiotherapy. He lives and works in Corna County in Adelaide, South Australia. And we have our little grounding practice, and then we have a lot of questions for you, Laz, and we appreciate you being here this morning, your morning, my evening. John's like, I don't know what he's doing over there.
Nor do I. Yeah, I think I even butchered, even after discussing the pronunciation, I think I butchered your first name's pronunciation there, Doc. So we're just going to go with Laws. So thank you for making it easy for us. So that said, yes, we kick off the show with an opening practice. If this is the first time for you tuning in, that's how we do it. We kick it off that way and we wrap it up that way. So that said, go ahead and get into a comfortable position, whatever that may look like for you. And if closing your eyes is comfortable and safe, then I invite you to do that too. Otherwise, just soften your gaze. Maybe lower your eyelids just slightly. Again, if that is comfortable and safe. And let's just bring our attention to our breath. And we'll just do 5 intentional and aware breaths together. Begin by emptying your lungs. Deep breath in. Hold at the top and release. Empty, empty, empty. Hold empty at the bottom. That's 1 deep breath in, filling your lungs all the way from the bottom to the top. Hold at the top and release, release, release. Holding empty at the bottom. That's 2 deep breath in through your nose, ideally. Hold at the top and let it go. Let it go. Let it go. Holding empty at the bottom. It's 3, 2 more. Deep breath in, filling from the bottom all the way to the top like a balloon. Hold at the top. And release, release, bringing your navel to your spine, squeezing out your lungs, empty, 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 holding empty at the bottom. And last one, deep breath in. And another extra little sip at the top. Hold and release. And as you release, start to bring some movement back into your body, maybe rolling your neck around, your head around, moving your fingers slightly, rolling your shoulders, trying to alleviate some of that pain that we are here to talk about today. So again, thanks, Doc Laws, for being here with us today. Very excited to get in this conversation and share your knowledge, your experience, your expertise with our audience. And let's kick it off with, let's just talk about basic pain, the basics behind pain. And I was in special operations here in the U.S. I was in the Navy SEAL teams, and we were told, pain is weakness leaving the body. But then we were also told that pain is a warning sign of something being wrong with your body, like an injury. And if you feel pain, you need to stop what you're doing and address that injury. What is pain actually? And is it necessarily a sign that something is wrong with our bodies?
Wow, the first part of that question is really complex, and the second part is very easy.
Great.
No, it's not necessarily a sign that something's wrong with our bodies. First part, I guess before I get stuck in, it's custom here where I live in Australia to, whenever you're in a situation like this, to acknowledge whose land I'm sitting on and talking to you guys from, and that's the land of the Kaurna people. It's written with a K. It's Kaurna. It's pronounced Ghana, like the country in Africa.
Okay.
And Kaurna nation has been living on this land for probably 40,000 years, which
wow.
is a very, very long time. It's the oldest enduring culture. The Australian First Nations people are the oldest enduring culture of our species, actually.
Wow.
And I pay my respects to First Nations people everywhere, wherever you are. If you listen to this, I pay my respects. Kaurna land was never ceded, never will be. I definitely dip my lid to elders past, present, and emerging and their connection to land, sea, and water. With equal respect, I sort of wade tentatively into this question that you asked, John, because it's for me, mind-blowingly complex. What is pain? And there's two ways I could approach that question. The easy way is, well, you tell me. You've had it. We've all had it. What is it? What does it feel like? What's the point? That sort of stuff. And I guess that's a really important aspect of the question that people like me in a clinical or scientific role have to hang on to all the time, because the expert of anyone's pain is the person who's experiencing it. And it's a really different question when you ask, okay, from your perspective as a neuroscientist, which is what I am, and a pain scientist, tell me about pain. That's I feel really comfortable with that. But if a person in front of me, like yesterday, I was seeing a person who had 35 years of pretty unrelenting back and neck pain. It's a very different scenario for me to be so presumptuous as to say, I'll tell you about your pain. Because they're the boss, right? They're the expert on it. So if I take the question as an open invitation to say, well, how do we try and make sense of it in the scientific field, in the clinical field? I would say that the best overgeneralized, oversimplistic answer to that question is that pain is a feeling that you get in your body that's unpleasant, and it makes you want to do something to protect that part of your body. And if you have that pain all over your body, then it makes you want to do something to protect the structure of your entire body. It's quite unusual to have pain all over your body. We normally have it located somewhere. And about 1 in 10 humans has persisting low back pain. That's the most common area to have pain.
Yeah.
About 1 in 5 humans has persisting pain. Good chunk of those back pain, as I said. And what you want to do when you have back pain is to protect your back. So that might be through seeking care, or it might be through moving differently, or choosing different behaviours. You might choose to not go for a walk or not sit in a chair for too long because you've got pain. So pain and I think this might sound really straightforward, but it's actually a real Will, you gave me full permission to use the most appropriate. I'm not by nature a swearer. I don't tend to swear in any context, except when I'm talking about pain sometimes. And I think that's because it's the language of suffering sometimes. Right? So, if you'll excuse what I'm about to say, this idea of pain being a feeling that's generated by you and the last organ to touch it. Remember those games? You're the last one to touch it.
Yep.
The last organ to touch it is the brain. So I tend to say, well, it's produced by the brain. Pain is a protective feeling, and to get your head around that in a really deep in your belly kind of way it really is a mindfuck, because it really it means you have to let go of some of the things that feel so intuitively sensible, the fact that it feels so much like there's something wrong in this part of your body is why it's so effective at getting you to protect this part of your body. But John, you talked about those conflicting messages about pain that you received in the Special Forces. Pain is weakness leaving the body.
Right.
And pain is a sign that something's wrong. But you can't coexist with those two understandings of the same thing, right?
right.
So that in itself is, okay, so what do I do? And in most pain scenarios in our lives, nearly every single pain scenario in our life does not involve tissue damage in any way, right? In fact, it stops tissue damage, right? So we'll be sitting here by the end of our chat, we'll be moving around in the chair a bit because something just niggled a little bit, something hurt a bit, but you're not damaging anything there. It's the pain that makes you do something to protect your tissues from damage. And that it works really well most of the time, but sometimes it doesn't work. And the times that it doesn't work are when a threat to the tissues, and normally that's what we would say is a mechanical threat, so it's a force on the tissues, some sort of mechanical force on the tissues. It happens too quickly for the inbuilt protective system, so we have these sensors all over our body that they don't know what pain is. They just know that this is an unusual force, right? Or this is an unusual chemical balance, or this is an unusual temperature, and they send signals into the brain via the spinal cord, just saying something's different here. And then the brain, the big kahuna, has to work out, is this something that we need to protect you from? And if it is, the brain fires into your consciousness a feeling that makes you stop what you're doing and change your behaviour, and that feeling is pain. If that force or temperature, so say a burn, if the change in temperature or the force happens too quickly, that system can't alert you to the problem in time to save you from damage, right? So a burn is a great example of that. Sometimes we just do not have the speed of response in our system. The other time that it fails, so we end up getting an injury, or we might talk more broadly and say pathology, something going wrong, is when the change happens too slowly, right? So the system's there to detect change. And if the change happens really slowly, so let's say you've got a really slow-growing tumour, really slow-growing cancer, the growth doesn't get picked up by our sensors because it's too slow a change. And we do experiments in the lab where we put on a slightly hot thermode on the back of your hand, and it never really hurts that much, but if we left it on for long enough, you would have second-degree burns without having experienced a lot of pain on the way because the change in temperature was too slow. Whereas if we put on a 60-degree thermode, you can respond to that pretty quickly and you can actually withdraw your hand from it. So the pain system fails to protect us really only under two conditions. It happens too quickly or it happens too slowly. And I guess the third is if there's something more important going on. And John, you'd have insight into that from your work in Special Forces. If your entire existence is under threat at a moment in time, the brain won't choose to produce a feeling to protect your foot from the blister.
Right.
Yeah, there's there's mechanical forces on your foot, and the system tells your brain that. It says, this is unusual forces. But your brain is also getting data that suggests your life is under threat here. And if you guys just imagine, if you were the executive controller sitting inside someone's brain and you thought, okay, do I protect the foot or do I stay alive? Listen.
Hopefully they're going to choose staying alive.
No-brainer, right? It'll choose staying alive. In fact, you guys might not be old enough for that, but do you remember Staying Alive?
The song.
Yeah.
Oh, yeah.
Like,
totally.
That should be a catch cry. Choose staying alive. So the brain is always prioritizing stuff, and it does that in the moment, even if you have had pain for years. Everyone who has pain for years will have moments in their life where they are entirely pain-free. It's just that during that moment they might be petrified or feeling nauseous or feeling in love or something else. The brain's producing these feelings with an agenda. And so to go right back to your question, what is pain? I reckon pain is a protective feeling, and it is produced when all the available information, right, the data coming from your body, the data stored inside your head. I mean, everything we've ever done is stored, really. Even though, things that you know that you don't know that you know, all that stuff affects whether or not your brain will decide to protect your body at a moment in time. And if it decides, okay, it's time to protect, you'll have pain. And if it's your whole body under threat, you'll have fear, for example. Or you might have fatigue. Right? And then we get into situations that are not uncommon at all, where people have all of those things. They have fear, anxiety, they have fatigue, they have low mood, they feel like, I don't want to see anyone. And these are all, and they have pain, they have stiffness. These are all feelings that are produced by your brain in very sophisticated and, in my view, mind-blowingly glorious ways, right? It's true. The fearful and wonderful complexity of the human it strikes me every day, that it can produce all these feelings that have an agenda for you, the organism, to keep you safe. The bummer is when they're being produced when you're not actually in danger.
Right.
And an accessible version or equivalent of that is post-traumatic stress, when you feel very frightened when there is actually no risk. The feeling's entirely real, right? No one doubts the feeling. It's a bit of a challenge in my field is that because we've thought for so long that pain is something that happens in your body and is sent to your brain if you've got an injury, then someone who has pain but no evidence of injury feels illegitimized, invalidated.
Right.
And try telling them their pain's not real. Try that. And the pain's 100% real, because pain is 100% every single time you have pain. It's a feeling generated by the brain in response to all the available data. It's not a personality problem. It's not you don't make it up.
Yeah.
Anyway, you can tell that when I get asked questions about pain, I've got a lot to say, right?
I love it. That's why we brought you on the show, is not to hear ourselves speak. We want you to talk.
So why don't we get a little nerdy and geeky and actually talk a little bit more about the brain? And I watched a lecture that you did, I believe is at the University of Washington. I think it was like 2017, and I was very fascinated about what you just said about how pain is really just a very subjective experience in a lot of ways, and it really is not just the mind and the body wanting to protect itself, but it also has it's influenced by the past experiences. It's influenced by the environment you're actually in that particular moment. And I was really fascinated by when you talked about neurotags and how they compete as well as collaborate in order to create a pain response or to shut down a particular response. So maybe we can dive a little bit deeper into the brain. I'd love to, pick your brain about what's going on there.
Yeah, well, good homework, Will. Well done, mate. That you've managed to find discussion of neurotags. So, for those many people who haven't heard that term before, neurotag is just another way of talking about a neural network. So a network of neurons and immune cells within your brain or within your spinal cord. So we now understand that if people have ever seen a drawing of what a spinal cord looks like on the inside, they would have seen a grey butterfly inside a white circle. And talk about the grey matter and the white matter of the spinal cord. And the white matter is neurons, like freeways, taking information up and down. And the grey matter is really just brain matter, right? That's gone down the spinal cord. I mean, it's all meant to be there, obviously, but we think about neural networks, so neuroimmune networks that I'll now call neurotags, exist all throughout that grey matter, from the spinal cord all the way up and all over your brain. And one way of thinking about the brain, and I think this is probably the favourite way among neuroscientists now at the moment. I mean, it's extraordinarily complex, right? There are billions of cells inside your brain. About half of them are nerve cells and about half of them are immune cells. It was only sort of 15 years ago that we even discovered that the immune cells do stuff. And they do a lot of stuff. So we talk about these neurotags, and you mentioned the idea of neurotags collaborating and competing for influence. And that's something when we're teaching physical therapists and doctors and scientists about neurotags, we talk about the principles that govern how they work. All right. So you did say, Will, we were going to go nerdy. You okay with this?
Yes. I'm okay with this. Okay. Yeah. I mean, I think, go for it. Let's dive in. We have a very sophisticated audience, so let's.
Well played, Will. Sophisticated. There you go.
I love it. Between the two of you, I mean, Will with the beard and the glasses, right, and you, John, with that your beautiful white-toothed, youthful look. You look like you're the real legitimate podcast. Like it's
we look like we're legitimate.
We are, Laz. We are.
No, I've heard. I did a bit of research. I've heard.
Good.
Anyway, let's go back to the nerd, Bill, because I love this stuff, and it really does, in my opinion, give great validation to people who are challenged by persisting pain, persisting feelings of stress and post-traumatic stuff, persisting fatigue, persisting hunger. And if we can understand how neurotags work, according to the common favourite model of how the brain works at the moment, it does offer some explanation but also hope for the future, I think. So neurotags, we can conceptualise anything that the brain does as being the result of neurotags being activated. So all the words that I'm saying now, we could say, well, that's because I'm activating the neurotags to make these words. All right, so you guys just both nodded, and I could say, well, we know you activated the neurotags that make you nod, right?
Right.
And all of the neurotags that do things outside of the brain, like behaviours or thoughts or feelings like pain or I need to go to the toilet or anything like that, or send a motor command, so a command to your muscles to make you move or to make you brace, not move, all of that sort of stuff. We can talk about that as one kind of neurotag. And then we have to remember that underneath that neurotag is only being activated because of the sum total of all the other neurotags that are influencing it. All right, so a single neurotag that makes you guys nod is being influenced by content of what I'm saying. My own nod, right? I just did it then, right? I can make you nod just by nodding, right?
Mirror neurons.
So, mirror neurons. Mirror neurons are parts of neurotags that influence other ones. So we can just go right down in this hierarchy. We've got these neurotags that span across the entire brain, and they're really big. They've got a lot of cells in them, right? They're really powerful and influential neurotags. Then if we could go right down to the area in the brain the size of a pinhead, and we would have little neurotags in there. And those little neurotags are influencing other ones that are a bit bigger, and a bit bigger, and a bit bigger, and a bit bigger. And until we get into the real action output neurotags. And when we start to think about the brain like that, all of the stuff that we've learned in pain science and pain management in the last 50 or 100 years starts to make sense, right? If we don't think about pain as the output of neurotags, then all the stuff we've learned about pain doesn't make sense. Right? It really doesn't make sense. And for example, we can look at the sort of experiments that we do in our lab. And one of the experiments that captures this, I think, really nicely and simply, and I probably mentioned it in did you say U of Washington talk that you looked at?
Yeah, U of Washington talk. Yeah, it was great.
I think that might have been the Bill Fordyce talk, and Bill Fordyce was from Seattle and changed healthcare around pain in the sort of 60s, 70s, and his family came to that talk, and it was all very emotional. It was lovely, very influential guy. Anyway, I imagine I talked about it there in the Bill Fordyce talk, that we do this experiment where we put a very cold stimulus on the back of the hand of supposedly normal, healthy volunteers, right? They're not entirely normal because they're volunteering for a pain experiment. Let's say aside from that, if we're being honest, they are abnormal because they're volunteering for a pain experiment. They're probably poor because they'll get some money for participation. They might be doing pretty badly in their studies, and this might give them a chance to, get a good relationship with the professor. Let's pretend they're normal people, all right, aside from that. If we put this really cold stimulus on the back of their hand and we show them just a visual cue, right, and we choose to show them either a red visual cue or a light blue visual cue, and just by that visual cue, their experience related to the stimulus on their hand can be very, very different. And without telling you what the difference is, I could just ask you, if you put a potentially dangerous stimulus on the back of someone's hand and you show them a red light at the same time, occurs together, or you show them a blue light, which scenario is going to give you more pain?
Red light.
Red light. It's intuitive, isn't it? And it makes a lot of sense, right? Red means hot. It means danger. Yeah. Right? Blue doesn't mean hot, and it often means, cool and, not, maybe safe, or certainly not danger. And in those experiments that we do in very controlled situations, so we control for everything we can possibly control for, right? We see that for some people, they get it's exactly the same stimulus on their hand every time. There's no change in the stimulus on their hand. But if they see the red light, some people will have an 8 out of 10 pain with the red light and a 2 out of 10 pain with the blue light. Consistently. Other people, it's very close. And there were 2 people in this one experiment I'm thinking of about 40 participants. There were 2 people for whom there was no effect of the light. And in neuroscience terms, we just call those people idiots. Because their brain's not, the light, the visual cue is not influential for them at all. And people have said, so were they colourblind? They weren't colourblind, but they sort of were in their brain. The cue didn't mean anything, right? And it takes us back to that idea of, the pain is not giving you a measure of what's happening at your hand. It's really giving you a measure of how convinced your brain is that you have to get out of this situation.
Right. Even when there's no stimulus, which is fascinating, right? There's like no stimulus. You're just looking at a color, and you're like, but you're also in this experiment though. Are you kind of leading your test subjects into like a potential narrative, like one is bad, one is good, or they're just figuring out that on their own?
Yeah, outstanding question. So just to clarify one bit, they always received a stimulus on their hand.
Okay.
Right? So the only thing that changed was the colour of the visual cue that coincided.
Oh, got it. Okay. So it'd always be some sort of, stimulus, but okay, got it.
Yeah. But in answer to your question, no. So in our experiment, nothing, right? It was very controlled. We didn't mention the visual cues. They were just there. And we did a few other conditions. So there was one where the visual cue occurred slightly before. That was another experiment, slightly before the stimulus on the hand, and that showed the same sort of responses. We were very interested in what happens if it occurs at exactly the same time. So we don't have enough time to develop an expectation of what's about to occur.
Yeah.
And in actual fact, that can mess with the feelings in counterintuitive ways, right? Because you get the red cue saying this is going to be hot, right? So if we created that expectancy, this is going to be hot, and then we gave them a very cold stimulus, then the individual can actually overcorrect, right? Because they're expecting 42 degrees, or you guys, what's that, 100
something.
Your old-fashioned archaic
Hot.
get with the program way of measuring temperature.
I don't know why we still use it.
No one knows why you still use it. All right. Anyway, so if their system was expecting a signal that would be consistent with 110 degrees Fahrenheit, and they get a signal that's actually, have to make this up, 70 degrees Fahrenheit, then we know that the brain is always looking for errors in its predictions. And that big error could be enough for the brain to think, whoa, I'm way off, and it creates a feeling of even colder than it really is.
Oh, wow.
Yeah. So expectations and predictions are really powerful neurotags that influence ultimate neurotags in advance. So talking about getting nerdy, the neurotags in that situation would be involved in finally determining how much your hand hurts when you have a cold stimulus paired with a red light. We have neurotags that represent red, right? So
right.
Neurotags of the color red. We have neurotags that link the color red to danger.
Yeah.
We have neurotags of something's happening on your hand. Neurotags of you're in an experiment. Neurotags of the experiment student, PhD student, it's a bit smelly today. We have neurotags of whatever caffeine's in your system or what you ate last night. We have neurotags that are representing how well you slept. Neurotags that are involved in your genetics, like people who are redheads, natural redheads, on average have a slightly more active sensory detection system for temperature change. All right, just on average. So you have these neurotags of what culture you live in, what are your past experiences in life, what's your general health at the moment. All of these things affect the pain you experience with a highly controlled experimental stimulus put on your hand. So much so that so we do other experiments, say with laser. We shoot a laser gun onto someone's hand or leg or something, and we deliver exactly the same stimulus 50 times, let's say, with no colours or cues, and there's no one else even in the room. The little laser machine's just sort of moving a little bit, zap, just does that, and they report how much each zap hurts. And the variability in that zap will be around about 3 or 4 points on a 10-point scale. And what that reflects is all the neurotags that are humming away inside our brains at any one moment. You know, they might just have the neurotag that's managed to win the competition that remembers, shit, I left the bath running at home, right? And that in that moment we zap them, they don't even feel it. They don't have it. They don't have pain because there's something else that's going on in the neurotags underneath. And then alternatively, you know, we then this other thing happens and you realise that you're back on the terps. Do you have that phrase? Your commitment to reduce your alcohol intake, you're letting yourself down a bit. And in that moment, we zap you and it hurts more because they're just this extra little neurotag for danger. So we don't talk about neurotags very often with patients, right? Because it's nerdy.
Sophisticated.
What we do talk about is what we call DIMS and SIMS.
Yeah, I enjoyed reading that. Yeah.
Yeah, you guys call them dumb sums, right? Or dim sums or something.
Dim sum sounds like we're going to go to a Asian restaurant.
Go get some food.
Yeah,
exactly.
Yeah.
Well, that leads you into the, so please let's get into SIMs and DIMs and your protectometer, right? Or your protectometer. which is great. And, I have here written down something you said, like pain equals evidence of danger in me, which are DIMS, minus the evidence of safety in me, which are the SIMs. So this maybe can kind of get us deeper into the mind. And I love this. I was digging into this protectometer, I guess is probably the proper way to say it. But yeah, please. I love this.
Well, I think you guys in North America, I think you'd be inclined to say protectometer. Is that right?
Yeah,
probably.
So.
And I would be inclined to say, I remember at the start before we started, I just said if you want an Australian accent, you just have to imagine that your IQ's dropped by 35 points. And then you say the same words and they just come out a bit differently. So this would be protectometer.
Protectometer, okay, yeah.
But you say it however you want. Like, that's the beauty of the word, right? It's a brand new word. There's no rules on how you say it. So the idea of the protectometer and DIMS and SIMS is really, it's just a metaphor, right? It's just a way of understanding what we currently think happens when you have pain, right, inside your brain. So we've been talking about neurotags, but we could easily just talk about DIMS, so evidence of danger in me. So back to that hand of the light example, the fact that it's a red light is evidence of danger. So that's a DIM, right? The fact that you're the experimental researcher has bad BO today and you don't quite trust them, that's a DIM. The fact that you just realised, man, I haven't slept well for 6 weeks, that's a DIM. The fact that you haven't slept well for 6 weeks is a DIM. And so we've done experiments where we deceive people about how much they slept last night. And they come into the lab, or this quite a long time ago, come into the lab and you basically have a fake sleep quality readout. And you say to them, we randomly allocate them to say, well, the data show us you didn't sleep very well last night. Right? Or the data show us you had a great night's sleep last night. And then we also have data about how good their sleep actually was. Right? So we now know that thinking you had a bad night's sleep is a DIM.
Wow.
So is having a bad night's sleep. But you could have a good night's sleep but think you had a bad night, and that's still a DIM. All right, so both of the things are important, how well you sleep and how well you think you sleep. And we could go through all these real, tangible things that tell your system there is some danger in me. You've just had a vaccine, right? Your immune system's responding to that. Or you've just had a virus, right? That's evidence of danger. So we know that if you're in the middle of fighting off a virus and we give you an experimental stimulus, it's going to hurt more, all other things being equal, right? Because your immune system is fired up, and we know that your immune system is really important, particularly in chronic pain, right? So we've got all these DIMs. And on the other side of the ledger, we've got all these SIMs, right, which is evidence of safety in there. So we've got a particularly attractive researcher doing the experiment. That's an evidence of safety. Or that researcher might remind you in some way, without you realising, of your mum, who you love very much and loves you very much. Alternatively, that researcher might remind you in some way, and you don't know this, you just pick up cues. Their voice, shape of their head, the way they walk might be the same as someone who's actually highly threatening to you. One thing I love, John, in your introductory mindfulness thing today was to remind us all, close your eyes if it is safe to do so. That's beautiful, right? Because we know for some people, the act of closing their eyes might be a DIM.
Right.
All right. So we can go through all that sort of stuff. And the protectometer and the DIM SIM idea, in fact, the consumers that we work with, so patient partners, a lot of our research involves a lot of what we call consumer advisors or consumer partners. I think in the US, you tend to call them patient partners. But what we hear from them is they start talking about this as their DIM SIM therapy. And they end up thinking, okay, well, I'm going to have to go into the office today to meet with the boss, for example, and that's a highly dangerous situation. What SIMs can I pack with me? what are the sims? So I'll make sure I've eaten well, slept well. I might take my favourite trustworthy person in with me. These are all things that have real life biological effects. They're not flaky.
Right.
They're real life biological effects. And the progression of the dim sim and protectometer idea just recent. So I've just spent a week on an island off Adelaide called Kangaroo Island, spectacular part of the world. In fact, I reckon New York Times might have ranked it in, I think, in the top 10 places to go. Anyway, you should go to Kangaroo Island.
Awesome.
I spent a week there rewriting this book on the protectometer, and we've updated it to think about an amplifier in the brain. And if you get a piece of information from your body to say something's different, all right, so we're letting go of this idea that you never get information from your body saying something's damaged or something's in pain. You just get data to say something's different. And then that goes through an amplifier, and the amplifier has 5 different sliders on it. And we get people to think through those sliders. So one slider is your previous experiences in life. One slider is your general health. One slider is your current environment. One slider is your beliefs about what this is, about who you are, about what context it is, all that. And one slider is your behaviours around that. And we get people to slowly work through all of those things and identify all the dims, so all the things that take the sliders up, because that's going to make pain and inflammation and immune activity worse. And all the sims that take any of those sliders down, because it's going to make pain and inflammation better. And that sounds like a really simple, dim sim model, but it actually integrates highly complex neuroscience and immune science from across many fields into a coherent way of thinking, okay, well, there's a lot of ways I can influence my pain, actually. And that means there's a lot of things that I could learn to get better at, to retrain neural pathways in order to reverse this. And I'm talking now about people with chronic persisting pain, in order to reverse this pattern of hypersensitivity that we know characterises people, almost without exception, characterises people with chronic pain.
With the DIMS and SIMS in mind, meditation and mindfulness, does that, I'm assuming, just based on the conversation that we've had thus far, if you meditated in a certain way or if you lived mindfully, it would affect your pain. Is that an accurate statement? And are there studies that prove this?
Yeah, I believe it's an accurate statement. I think it's, but the second half, no, I think there would be studies, yeah. It's whenever we look for evidence whether an intervention works, right? So our research group does research from what we would call the discovery end. We only ever deal with real life entire humans, so we don't do experiments with animals or taking parts of animals or that. We do experiments with human volunteers. And then we do everything from there right up to these clinical trials or population level interventions. Right. So if we're going to answer the second part of your question, does an intervention work? At the moment, as far as evidence is concerned, we need to do a randomised controlled trial of that intervention. And we need to pick a control treatment that matches the intervention for everything except the thing we think is important. All right. So randomised control trials are very expensive and very difficult to do well. We've got about 5 running at the moment. They cost about $1.5 million each to do a randomised control trial. So, it's not a trivial thing. So to answer your second question, there are definitely studies. There's a lot of studies that involve experiments where they've taken highly skilled meditators or mindfulness experts, and they deliver certain stimuli to them, and they ask them to put themselves into a meditative state or perhaps into a mindful state, which is more about somatic, so targeting attention across the body somewhere. And they show that the same stimulus hurts less when they're in that state than if they're not. And it hurts less for them than it does for someone who's a novice or an untrained meditator. So there's very good experiments like that. There's a group in California who's done a lot of work with professional meditators, if that makes sense. Like people who have been, that's their thing, monks and nuns in Buddhist tradition or something like that. And they go into the brain scanner and go into a meditative state, and you see these very different activations of the brain in response to the same stimulus. So there's very compelling evidence that getting better at meditation and at mindfulness allows you to have a greater influence over what your brain does when it's, for example, under threat, for example, with a stimulus. But most of the time, we're playing football and we're about to rupture our cruciate ligament. We're not going to think, I'll just go into a moment of mindfulness. Right?
Right.
But when we start talking about people who are challenged by persisting pain or persisting post-trauma, then there is very compelling reasons to become highly skilled at meditation and mindfulness. One, for its clear effect on what your brain does with data. But another one is that one of those sliders I talked about was general health. We know that daily practice of mindfulness on average is better for your general health. But we also know that when you go into a mindful state, even in that short exercise that you did at the beginning, you immediately change the activation of other systems in our body, so that the sympathetic nervous system or the autonomic system.
So would you be saying in those states you're kind of creating sims, like more safety in me? Is that?
Yeah, absolutely. You are creating sims of a wide variety. You're creating sims in the moment of I'm calm. I've got a lovely voice here talking me through my breathing. I'm safe. These are very powerful cognitive cues, in my view. The tone of voice, Mark Jensen, who's an outstanding pain researcher, clinician, and does a lot of hypnotic suggestion as part of his interventions. He's at U of Washington. He does a lot of work on this, looking even at the tone of voice and the intonation that you use when you're walking someone through one of these sessions changes your pattern of brain activity. And when you change your pattern of brain activity, your whole body is involved in some way, and this incredible system of sensors out there in your body detect, we're in a safe place.
Yeah.
Right. So not only do you have the immediate cognitive cues, auditory cues, metacognitive cues, you actually have real life biological signals coming from your body that say you're safe, you're safe, you're safe.
Yeah.
All of those signals are very, very small. But remember the complexity of the Neurotag story. You get enough of them and you start to see genuine shifts in the ultimate influence, because Neurotags are competing and collaborating for influence. You change your blood pressure in 20 seconds when you do an exercise like that.
I meditate every time I go to the doc.
Out there, yeah, all of the sensors in your body, they detect the change in blood pressure.
Yeah,
they detect your change in heart rate. They detect that, hang on, we've got a little bit less adrenaline, or I think you guys might say epinephrine. It notices less cortisol. It notices. In fact, it can be anti-inflammatory. And we have detectors out there to say, hey, we've just had a reduction in what we call pro-inflammatory cytokines flying around in our blood.
Wow.
Right. So we are, and I say this so many times when I'm in this context, we are so fearfully and wonderfully complex that to attach the meaning of a persistent pain to a dysfunctional pathology in a single part of your body is, to me, denying some of the most beautiful scientific developments humanity has made over the last 100 years. We are a unified organism. You can't do anything without somewhere else in your body detecting you've done it. Yeah, and I love it, and it's full of possibility, but it has a dark side as well. I don't know if you think about getting onto that, but the adaptability, the incredible cleverness and capacity to learn that we have has a dark side, right? Because it makes us more sensitive to some things. If we keep producing pain, the system gets better at producing pain. So you end up having pain when you're not in any danger anymore. And you said, I think one of you mentioned the idea of how our body learns. I think it was you, John, said, our body learns pain. And this is a at once very intimidating reality and exciting opportunity for scientists, healthcare professionals, and people challenged by pain and their friends and partners and family, because it says, if you've had pain for 3 years or 6 months, the protective buffer that is being offered by your pain, right? So pain is all about protecting us, is getting bigger. And it can get so big that it stops you doing the very things your body needs you to do to fully recover. And this is a really challenging situation, because the problem now is not in the body part that hurts. It might not be perfect, no worries, but the problem is in the system. We say in the pain system. And there's a handful of very vocal people out there, retired health professionals or young researchers. There's a handful of them who hate this idea. They hate the idea of the system being able to learn, or even the idea that there is a system. But the reason I think it's really important to use these sort of terms, we don't have a pain system like we have a nervous system or a musculoskeletal system, but we have a system that is there looking after our body that consists of neurons, immune cells, endocrine, gut, muscles, bone, thoughts, all this stuff that together I think we can call a system. But more important, our patient partners, consumer advisors say, well, whatever you call it, we're calling it a system, because we can make sense of it if we think about it. It's the pain system that's become hypersensitive. And it's the pain system that we now need to train back to normal levels of hypersensitivity. And we could say back to normal levels of sensitivity. We could say exactly the same thing about post-traumatic stress. The protection of your whole body system. Let's say maybe the fear system is hypersensitive because it's adapted over time, or it's had a single event that makes it absolutely important to protect you from a whole range of situations. But when those situations include the very things you need to do to have the life you want, then we've got a problem with fear system hypersensitivity.
Right.
Does that way of thinking make sense?
100%.
Yeah.
So if we're in that situation, treating persisting pain or persisting fear as though it's a problem in a particular part of your body seems to me like a moronic thing to do. We have to train. We say we train the brain and the body, and we have to retrain it over time. No one can do anything to you to remove this hypersensitivity. Well, you got to retrain your system, and that's the real challenge.
I was shocked at you said the first line of defense for back pain, and I guess this can almost go for any pain, is education and advice to remain active. And I was like, wow. And then, but then I guess that can lead us into so why are people so attached to their pain? Is it because the story they keep telling themselves and the relationship because of that story that they continually to live in their environment, and therefore they're just continually looking for, saying something like, oh, my back is always bad, or I always have back pain. And therefore our brain, you said here that, I think it's any and all data is stored to help make a decision, and your brain uses all incoming data. So if you put yourself into this mental state of my back is in chronic pain, I guess we keep going out and look for evidence for that pain. And I just thought, I don't know where you want to go with that, but
I want to start any discussion like this with a really emphatic reminder that having persisting pain is brutal and it is really hard to recover. I want to make that really clear, and that there are contributors to your likelihood of developing chronic pain that are way beyond your control. There's some genetic involvement. There's a whole lot of factors about how you grew up, how where you lived, what you've eaten all your life. Your social determinants of health are really important. All that sort of stuff. There are among all of those things, there are things that we can change. There are things that we can't. And the things that we can change involve that amplifier. You can change your general health. You can't change your past experiences, but you can change your understanding of how they might be linked to this situation. And you started off by saying, sort of almost talking about, why do people keep, you didn't say this, but keep searching for the single cure or something like that. It's a really common observation. You could easily ask, why is this such a big problem in humanity? Chronic pain, by any metric, is the most disabling health problem we have. It's the most expensive health problem we have. Right? And it affects, as I said before, 1 in 5 people, 1 in 10 people really badly. So
it's also a huge moneymaker.
Well, there's there's a part of the answer. Right? So we have developed in the healthcare professions entire professions that deliver care for people with chronic pain as though we still understand pain like we did in the 1950s. Right? They deliver care for chronic pain as though it is an acute injury that hasn't healed yet. Now, there is an occasional person who has an acute injury that hasn't healed yet. Right, and they do well to fix that injury. They're very unusual situations, but they exist. But even that person will have a pain system that has learnt to be more efficient over time. So it will feel worse than it is. And we've got to be really, really sure when we talk about this that the pain is what you feel. All you know about this is your pain. And we can't slip into even phrases that we don't even think about. Like as a health professional, we spend time trying to teach health professionals not to say things very well-meaning like, "Look, I know for you, your pain is real," right? Because what that actually implies is it's not for me. We have to be really careful about it. Or your pain feels your pain. You feel like you have more pain than you have. That's an erroneous statement. You can't feel like you have more pain than you have. That's what you feel is the pain that you have. Right? But as health professionals, we need to be really careful not to say those things, because people in pain have spent the entire time being in pain dealing with people who don't believe them, because those people have an old-fashioned understanding of pain. That is, if you don't have an injury, you can't have pain. Right? So why do we persist in searching for a single cure or trying to allocate pain to a single source of the body? Part of it is because that's how we used to think pain worked. Why is it so hard to change what we think about that? Well, because it feels like that. It feels like there's a problem in exactly one place. That's where the pain is. And that's why pain is so effective. We've evolved to have such a compelling feeling. It would be useless if pain was, you sort of felt pain in your relationships or in the fridge or something. That would be stupid. We feel it in a given anatomical part of the body. It's compelling. So one reason is that it feels like that. Another reason is that healthcare professionals have been very slow to change their own understanding of the problem. And I think, John, you have touched on one significant contributor to that is they feel like it will undermine their income, their identity, and their livelihood. So the structural changes that need to occur inside our healthcare systems around pain are significant. It's an understatement.
Yeah.
And they're actually more significant in most parts of the US than they are in most parts of Australia, if you like, right? Because we have universal private health insurance, and healthcare professionals don't get paid according to how many treatments they deliver. Whereas in a lot of contexts where you guys are, it's a really strict fee-for-service model. So it's in everyone's interests for the problem to not get fixed in a way.
Right.
And I know in some jurisdictions, I think in California, in the workers' compensation scheme, it extends into the legal frameworks of care, so that there's actually an advantage to being more disabled for the lawyers, and perceived advantage for the clients. I don't think that's a real advantage because they're more disabled. So why doesn't it move? Well, I think it does come down to education. And that's why, 5 years ago, 6 years ago, I set up a charity here in Australia that is called Pain Revolution. And anyone can go and look it up, painrevolution.org. And what we do is we are specifically targeting the way healthcare professionals understand how pain works and the way the general public understands how pain works. Because as long as the general public is coming in and asking for treatments that we know don't work, right, or we know are risky, then healthcare professionals sort of have to deliver them regardless of what they think. So we need to get the general public to understand how pain works and what the pathway to recovery is most likely to be. And we need to get the healthcare professionals to understand that. And then the thing that is the most challenging for us, and will be very challenging in where you live, is getting in place the funding streams to support that. And the levers. In Australia at the moment, if you have chronic pain and you're not on a compensation system, so you weren't injured at work or you don't have life insurance, and you can't afford to pay $150 a session for a good allied health professional, then you cannot access care for chronic pain. There is no avenue for you. And I imagine there'll be places in your country that will be very similar to that.
There are.
So I think we need a revolution because what is completely clear in chronic pain is the most effective treatments we have are education. So you understand how pain works and you understand what the best things to do are. And they are also psychological and active therapies. So mindfulness, meditation, that we know they're good things to learn how to do, to move, stay active. Movement is so, we were talking about the effects of mindfulness. The effects of movement are profound and multi-system as well. Even imagining movement. If you can't move, if you hurt too much to move, imagining movement will deliver SIMS into your amplifier. You know that.
Laws, I just got to interrupt you real quick because our business partner, mine and Will's business partner, Dr. Teresa Larson, doctor of physical therapy, she's actually who introduced me to you and your work. And she always talks about motion is lotion and how it's not just for your body, but it's also for your mind and how you handle different things in your life. So I love that you hit on that as we're coming to an end. That said, just keeping an eye on time. I, again, want to respect your time.
Thanks, mate.
I know we're wrapping it up. So if people hear this, when people hear this, rather, because I know we do have some listeners, how can they find you if they want to find more information on you and your work? What's the best way for them to find you?
Well, I'm pretty easy to find because I've got an unusual first name, right? So my first name is actually Lorimer, which is French for bridle maker, apparently.
Oh, wow.
But I'm easy to Google, but it'd probably be better not to, don't search for me, right? Search for all the groovy stuff that's out there. And Pain Revolution is one site that you could start at.
It's a beautiful site.
painrevolution.org. And then you just start exploring. And, we in this book that we've co-writing with a guy called David Butler, who's a national treasure in Australia. And in that book, one of the first pages is we ask people to complete their open-mindedness scale, right? So if you're challenged by persisting pain and you want to take the most current contemporary approach to this problem, you're going to have an open mind, because the most current contemporary approach goes against a lot of principles of treatment of chronic pain, because the emphasis is on you have to retrain your brain and body over time. So you're going to need a coach to help you do that, to strategize, to learn skills along the way, to become good at meditation and mindfulness. Not just do it, become good at it.
Right.
You have to practice. You have to learn stuff, because this is all ultimately about neurotags. This is all about neural pathways, and we have to strengthen the neural pathways that produce safety messages within the brain. I mean, a thought is a nerve impulse, right? It's not this flaky thing. It's a real-life nerve impulse, and we want to try and retrain the neurotags that create thoughts that are DIMs, all right? But you're going to have to do that yourself, so you have to have an open mind. And we have this open-mindedness scale where people rate, okay, how prepared am I to take on this challenge and this pathway forward? It's like slowly getting off heavy opioids. You got to take it slowly. You got to learn how to manage your system, right? And if you're not on opioids, then you've got an advantage there. But you still have to learn stuff over time and slowly train and get a coach. And if people rate themselves as nothing works for me, nothing will ever work, right? Then we say, fair enough, that's the place you're in. Don't bother with this strategy.
Closed mind
approach. Because there's no point. There's absolutely no point. So you do need courage, you need patience, you need persistence, and you need a good coach. And what Pain Revolution's trying to do is to create more good coaches. And I know there are good operators in North America out there. The company that sells my books is called neugroup.com. So if there are health professionals listening, look up neugroup.com. And I think also North America, OPTP sells books that I've written. And there are other good books. There are some books that are effectively rip-offs of mine, so they're very good.
Love it. Love it.
Anyway, there's lots of places you can go, but you got to change your mindset into, okay, I'm not looking for someone to fix this now. I'm looking for my pathway towards improvement and for many people, ultimately for recovery. But it's a journey.
Well, it's nice you came full circle, because you started with saying pain is a mind fuck, and here we are talking about first thing you need to do in order to release persistent pain and kind of begin to bring more of those sims into your life. And all the things we talked about is just having an open mind, instead of just looking for the quick fix or, the next cortisone shot or, whatever the next pill is going to come on the market, because that's just really masking the pain, I'd imagine. The
most challenging thing for, in Australia, they're called pain specialists, medical specialists in pain. The most challenging thing for people with chronic pain in front of those guys and girls is that they don't have any drugs that have good evidence of efficacy. They don't have any procedures that have good evidence of efficacy. I mean, there are occasional exceptions to that, but if we're just talking about pain, the very best treatments that exist are around learning about your pain, learning how to work your amplifier, learning mindfulness, cognitive behavioural skills, slowly becoming more active. Movement and load, you'll be on the right road. Load and move, you'll be in the groove. Motion is lotion.
Love it. Teresa's going to love this. Yeah. Loz, it's been so great having you on here. Will, if you would, just to run us through a quick grounding practice, and we'll wrap it up if you've got time.
Well, hey.
Maybe a couple breaths.
Let's put us in, some safety in me moment, right? We're just going to take a few breaths, and we're going to do a little a parachute breath. So we're just going to take 3. We're going to take a really a robust inhale really quick, and then we're going to take a long exhale out the mouth. Or just imagine yourself as you exhale like you're kind of a parachute floating down to the earth. If you close your eyes if you're safe. If not, keep your eyes open. Ground yourself as much as you can. Exhale out. Try to get all the way empty if you can. And let's take that big hit of an inhale. Exhale out slow. All the way out. Again. Really softly, very gently. Go easy. Be patient. Exhaling, exhaling, exhaling. And one more. And there we have it, gentlemen.
There we have it.
Laz, it has been such a pleasure. to have you here and teaching us all about pain. And it's amazing. If anyone wants to really just type in Dr. Lorimer Moseley on YouTube, and you'll have tons of videos that'll come up, and you can really get down the rabbit hole that John and I went down. And it's just fascinating work that what you're exploring and understanding about pain. And thank you for sharing your wisdom here today with us. And it really helps. It's helped me a lot.
Well, congratulations for the work you're doing. It's such an important offering, and I love the audience that you're targeting.
Thank you.
Like me. And it's really good. Congratulations, and thanks so much for having me on your show.
Pleasure. All right. Well, until next time, everyone. Take care. Peace.
Ciao.
Thank you.
Ciao.
Thank you for joining us today. We hope you walk away with some new tools and insights to guide you on your life journey. New episodes are being published every week, so please join us again for some meaningful discussion. For more information, please check out mentalkingmindfulness.com.